we're saying the variance of our portfolio is equal to, weight 1 squared times sigma 1 squared plus weight 2 squared times sigma 2 squared plus weight 3 squared times sigma 3 squared. A whole bunch of these. And then we're going to say, okay, well, let's just take the biggest one of these variances and say it's sigma 1 squared. Well, then we know that this is going to be less than weight 1 squared times sigma 1 squared plus weight 2 squared times sigma 1 squared, because this is bigger than that, plus weight 3 squared times sigma 3 squared, because this, weight 1 squared times sigma, because that's going to be bigger than that, and all these other ones. So what we get is the variance of our portfolio, and we're going to have n of these, and each one of these things is 1 over n squared. Sigma 1 squared plus 1 over n squared, sigma 1 squared plus 1 over n squared, sigma 1 squared. So we're going to have n of those terms. So we get n times 1 over n squared times sigma 1 squared is just sigma 1 squared over n. So whatever the variance is, it has to be less than this, because we took the biggest variance in our portfolio. The asset had the biggest variance. So you can see that this is fixed, so the numerator here is fixed. All that we can change then is this denominator, the n. And as n goes up, then this total thing, this ratio, is going to go towards 0. So that's saying that if we could find a whole bunch of different assets that were independent of each other, and we could find a lot of them, then adding more independent assets into a portfolio is going to drive this variance down. That's the idea of diversification. And that's how that's how we get to this equation in the book. Now the problem is, what have we assumed? We could find a bunch of independent assets. Right, so this only works if we could find a bunch of independent assets, and that's the problem that we're really thinking about. That's why we can't really do this. You can't typically, in a market, find a fully diversified portfolio that has no risk. That's what that variance, sigma p squared driven to 0, would suggest. And why is that? Well, it's because of things like the global financial crisis. There are certain risks in there where assets don't move independently of each other. So during the global financial crisis, everything went south. Right? It wasn't that shares went bad and bonds went good. Everything was doing poorly. Banks were falling over the place. Government bonds were rising risk. People were worried. Right? People were so desperate to find somewhere to put their money that literally people in Australia took, I think, about $10 billion out of the banks. So our Reserve Bank actually had to print more money so that the banks could hand out the money to the people who were coming into the banks, NAB, St. George, and saying, I want to cash out my deposit. So people were racing the banks, getting their money. Where was the money going? And the answer is, we really have no idea at all. All this money disappeared out of the banks. Where'd it go? Went under some people's beds, got put in jars in their backyards. There was all sorts of crazy stuff happening. People were really worried. People actually thought Australian banks would collapse as well, because all these banks overseas had collapsed. So people were concerned that Australian banks were going to collapse. So that in a sense there was this mini bank run where lots of people came in and took their money out of the banks. Then what happened was, I think it must have been Kevin Rudd at the time, Kevin Rudd made a promise. I'm going to guarantee your banks, which the Australian government already did, but there was this performance there. What that happened then was a lot of people took their money out of the hedge funds and mutual funds and different sorts of funds around Australia and took them out and then put them into the banks. So what you then had was kind of a run on these funds. So the funds started complaining, hey, you've guaranteed the banks, we're getting creamed here. Right? All our investors are coming in demanding they get their money out of our accounts. So there was a bit of a run on the funds, and that was a problem as well. So all of these assets moved in the same direction. Everybody's worried. People were buying crazy stuff like gold. People didn't think that there were any assets that were safe. So when I'm saying that we need assets that are independent of each other, they'd even have to be independent of something like the global financial crisis, which we know is simply not true. So there's some amount of correlation between all assets. So that's what we tend to actually see in the market, is we tend to see that, in fact, there's some minimum level of market risk. And that's due to this residual correlation across all assets. The reason why you can't drive the variance of that portfolio to zero simply by buying more and more independent assets. So we're going to assume here, and assume for this subject, that there is some level of market risk. And where does the market risk actually come from? The market risk actually comes from all of those covariance terms. Right? So we saw here that the second term on the right there is 2 times the weight in I times the weight in J times the covariance between I and J. That's going to hold true for every asset and its relationship to every other asset in your portfolio. So you've got a lot of assets. What we're going to talk about later is you can have a lot of those covariance terms. So there's going to be one term in there for the variance for each asset, but then there's going to be n-1, all of the other assets in there, times the covariance terms. All of those covariance terms will not disappear. And that's where we get the market risk from. So we might see that, that these weight squared times the variance of the asset squared, that those terms roll when we have a large portfolio with a large number of assets in them, that term's going to go to zero. So the term here on the left-hand side of these two equations down the bottom, those terms all go to zero because the share of any particular asset is very small, so the weight squared is even tinier. The more different assets you have in there, that's just going to drive the sense that weight squared times of covariance to zero. But what you do tend to find is even though that left-hand terms disappear, the right-hand terms, the covariance ones, don't. Because every asset that you add in a portfolio adds n times the number of covariances. Because if you've got 100 terms, you've got 100 assets in your portfolio, and you add 101th asset, you have to worry about the correlation between the 101th asset and the other 100 that you have in your portfolio. The sum of all those covariances doesn't go to zero, and that's why you wind up with this what's residual market risk. It's due to these correlations between all of the assets altogether. And even though those individual correlations might be quite small, summing them up leads to a relatively large term that doesn't go to zero.